Hi folks, welcome to day 3 of our extra credit unit. Today we're going to be working out of section 9.3. If you haven't already done so, make sure you go back and watch the day 1 and 2 videos first because these do have to be done in sequential order. So make sure that you do them day 1, day 2, then day 3. Alright? Today we're going to be learning about something called the unit circle and how to find trig functions of any angle. So a lot of times we'll just have like a ray, right? Like this blue line here, this blue arrow. A lot of times we'll just be like given some ray in math or in physics especially. All right, and when that happens, we still need to be able to work with these and manipulate these rays. So one of the ways that we can do that is by relating it to trig functions. So if we define our angle theta like this, with our r being the radius of this circle, then our trig functions are defined as follows. The sine of theta, all right, if this point here is x comma y, then the sine of theta is y over r. All right, cosine of theta is x over r, and tangent of theta is y over x. Cosecant, which remember is 1 over sine, is r over y. All right. Secant is r over x, and cotangent is x over y. With the caveat that y can't be 0, x can't be 0, and y can't be 0. And in the bottom here, x can't be 0. All right, because you can't divide by 0. R is assumed to not be 0 because it's defined as square root of x squared plus y squared. So, here we have our 6 trig functions defined in terms of a point. Now this is really helpful because remember that r, because of the Pythagorean theorem, is equal to square root of x squared plus y squared. All right. Now this is going to be really helpful because now if we're given a point on the Cartesian plane or normal coordinate plane, we'll be able to find the trig functions of it. And that's because of this thing here. This is a very convoluted version of what I've drawn, except that instead of just some random point and random angles, this has all of your big angles going from our 0th angle around counterclockwise, because that's how you define angles in math. You have to go counterclockwise. So we have our big angles along the lines, and those are all in degrees. But then you can see we also have like the pi version. Remember, that's in radians. And then you have your x and your y. Now the unit circle has a radius of 1. So part of why this is really nice is because if you know that your angle is like 30 degrees, then you already know what your sine and your cosine are, because you know that it's just y over 1 or x over 1. Right? That's the nice part about using the unit circle, is then it's really easy to see given our special angles, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. All right, all of those angles are included in the unit circle, so that's part of why it's super nice, because those are all like super common angles. All right, let's go ahead and try out an example. So I have my coordinate plane, and I have this point here on a circle, and that point's at -4, 3. Assuming that we have our r and our theta, we're going to try and find our 6 trig functions. So I know that x is -4 and y is +3. I now need to find my r. Remember that r is defined as the square root of x squared plus y squared. So that means r would be -4 squared plus 3 squared. It's really important that you're actually putting these parentheses around your numbers. Otherwise, this is going to turn out as a -16 in your calculator when it should be +16. So I have 16 plus 9. Which gives us square root of 25. Working with positives, we get r equals 5. All right, so we have x equals -4, y equals 3, and r equals 5. -4, y equals 3, r is r is +5. All right. So sine of theta, y over r, we get 3/5. Cosine of theta is x over r, -4/5. All right. Tangent of theta is y over x. Okay. That gives us 3 over -4, or -3/4. All right. Cosecant of theta. You get r over y. All right. So 5 over 3, 5/3. All right. Then we're left with secant of theta, which is r over x, which is 5 over -4. And last but not least, we have cotangent of theta, which is x over y. All right. X is -4, y is 3, so we get -4/3. So that's all you're going to be expected to do in terms of working with trig functions of any angle. Is just the ability to take your x and your y, find your r. After you find your r, you just use your definitions, all right? My strong recommendation is you should write down your definitions in terms of x's, y's, and r's, and in terms of opposites, adjacents, and hypotenuses, because those are all going to be super useful for your Chapter 9 test. All right, that's all I got for you today. Thanks so much for watching.